Hello everyone. So today we will see some questions regarding the states of matter. So let's start. Disclaimer slide which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. So let's start with question number first. A mixture of NH3 and N2H4 is placed in a sealed container at 300 Kelvin. The total pressure is 0.5 atmosphere. When the container is heated to 1200 Kelvin, both substances decomposes completely according to the equations given here, this and this. After decomposition, the total pressure at 1200 Kelvin is found to be 4.5 atmosphere. What is the percent of N2H4 in the original mixture? Assume ideal behavior. Options are 35%, 40%, 75%, or 25%. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option number D. Let the moles of NH3 and N2H4 in the original mixtures are N1 and N2 respectively. From given decomposition reaction in the question, 2 moles of NH3 produce total 4 moles of N2 and H2 and 1 mole of N2H4 produce total 3 moles of N2 and H2. Hence, total moles after the decomposition is 2 moles of NH3 N1 plus 3 moles of N2H4, that is N2. So 2N1 plus 3N2. Ideal gas equation is PV equals to nRT. So putting the value in this equation, we have two equations, namely first and second. On dividing the two equations and rearranging, we get this equation, or we can write it as N2 divided by N1 plus N2 will be equal to 1 by 4. So we have to find out the percentage of N2O4, that is N2 divided by N1 plus N2 multiplied by 100, which is coming out as 25%. Okay, moving on to the next question, question number 2. For gaseous state, if most probable speed is denoted by C star, average speed by C bar, and mean square speed by C, then for a large number of molecules, the ratio of these speeds are. The options are given here. First ratio is 1.128 is to 1.225 is to 1. 1 is to 1.128 is to 1.225. 1 is to 1.125 is to 1.128. 1.225 is to 1.128 is to 1. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option number B. So we known by the theory of this chapter that the probable speed C star is equal to this. C bar, that is average speed, is given by this, and C, that is mean square speed, is given by this formula. So on getting the decimal values of these under root thing for gaseous state of any molecule, and for carbon especially, the ratio is coming out as 1 ratio 1 is to 1.8 is to 1.225. So the option B is the correct answer. Moving to next question, question number 3. When 3.2 grams sulfur is vaporized at 450 degrees Celsius and 723 mm of Hg pressure, the vapors occupy a volume of 780 milliliter. What is the molecular formula of S vapors? Options given are S2, S4, S6 and S8. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be D option. So given that P is 723 mmHg, so on converting it to atmosphere divided by 760, so it will be coming out as 723 divided by 760, and weight is given as 3.2 gram, right? So the temperature will be converted to Kelvin as given in degree Celsius. So plus 450 plus 273, it is coming out at 723 Kelvin. So volume will be in liters, that is 780 divided by 1000. And we apply this equation, PV equals to nRT, and can be written as given mass upon molar mass. And by rearranging the terms, we get the molar mass will be equal to PV, molar mass will be equal to WRT upon PV. And on putting the values and by solving the equation, we get the molar mass equals to 256. So since 32 gram sulfur has one atom of sulfur, 256 gram sulfur has 256 divided by 32, that is 8 atoms of sulfur. So the molecular formula will be S8. Hence option D is the correct option. Moving on to question number 4. What is the difference in the density of dry air at 1 atmosphere and 25 degrees Celsius and moist air with 50% relative humidity under the same condition? The vapor pressure of water at 25 degrees Celsius is 23.7 torr and dry air has 75% N2 and 24.5% O2. So options are 0.005 kilogram meter per cubic, 0.007 kilogram per meter cubic, 0.01 kilogram per meter cubic, or 0.05 kilogram per meter cubic. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option number B. So how we find out this? So the M of dry air, that is mass of dry air, will be M1 of O2 into X1, that is mole fraction or percentage of O2, plus M2 into X2 for N2 divided by total percentage X1 plus X2. Putting the values in this equation, we calculated the M of for dry air will be 28.98 gram per mole inverse. So D, that is density for dry air, will be Pm of air upon RT, and putting the value, we get the density as 1.184 kilogram meter cubic inverse. So relative humidity is given as 50%, which will be equal to partial pressure of H2O in the air upon vapor pressure of H2O. So P of H2O will be coming out as 0.50, that is relative humidity, multiplied by the vapor pressure, that is 23.7 torr. And after calculating it, it is coming out as 11.85 torr. And on converting it into the atmospheric unit, it is coming out as 0.0156 atmosphere. Hence option B is the correct answer. Moving to the next question. Question number, okay. So percentage of H2O vapor in air will be equal to 0.0156 into 100 divided by 1, which will be equal to 1.56%. So percentage of N2 and O2 in air will be 100 minus 1.56, that is 98.44%. Now the M for mass for wet air will be the same, applying the same formula here and putting the values, we are getting it as 28.81 gram mole inverse, and therefore the density for wet air will be this much on calculating, 1.177 kilogram meter cubic inverse, and the difference will be 1.184 minus 1.177, that is density of moist air minus density of wet air, which is coming out as 0.007 kilogram meter cubic inverse. So this is the answer of this question. Moving on to the question number 5. In a spinel structure, oxide ions are cubical closed packed, whereas 1/8 of tetrahedral voids are occupied by A ions and 1/2 of octahedral voids are occupied by B ions. The charge present on A and B ions will be, options given are A2 positive, B3 positive, A3 positive, B2 positive, A4 positive, B2 negative, A negative, B2 negative. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer is option number A. So in cubic closed packing, there will be 4 oxide ions. So typical formula will be Ab2O4. Now each unit cell contains 8 tetrahedral voids. So 8 multiplied by 1 by 8, that will be 1 A ion. And each unit cell contains 4 octahedral voids. That is 4 multiplied by 1 by 2 occupancy. So this will be 2 B ions. Hence the formula will be Ab2O4, and A has +2 charge on it and B2 has +3 charge on it. We just equate the oxidation states here because O oxidation state is -2 and 4 times 2 will be 8. So we equate the equation and putting these value which will satisfy the equation. So A will be +2 and B2 will be +3, and the formula will be Ab2O4. Moving on to the next question, question number 6. The given graph represents the variation of Z, that is compressibility factor given by PV by nRT, versus P for 3 real gases A, B and C. Identify the only incorrect statement. So this is the diagram given, and on the basis of this we have to identify the only incorrect statement among these 4 options. So options are, for the gas A is equals to 0 and its dependence on P is linear at all pressure. For the gas B equals to 0 and its dependence on P is linear at all temperatures. For the gas C, which is typically real gas for which neither A equals to 0 nor B equals to 0, by knowing the minima and the point of intersection with Z equals to 1, A and B can be calculated. And last, at high pressure, the slope is positive for all real gases. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option C. So van der Waals equation is given by P plus A by V square multiplied by V minus P. It will be equal to RT. So when A is equals to 0, P times V minus B equals to RT, or PV equals to RT plus PB, or Z will be equal to 1 plus PB by RT. Thus Z will be greater than 1 and increases with increase of pressure. Hence option A will be the correct option. But we have to find out the incorrect one. So when B will be equal to 0, this term will be equal to RT and PV plus A by V equals to RT, and we find out that Z will be equal to 1 minus A upon VRT. Thus Z is less than 1 in this case and decreases with the increase of pressure. Hence B is correct. Now D is also correct and only wrong statement present is C. Okay, so moving on to next question, that is question number 7. At 100 degrees Celsius and 1 atmosphere, if the density of liquid water is 1 gram centimeter cubic inverse and that of water vapor is 0.0006 gram centimeter cubic inverse, the volume occupied by water molecules in 1 liter of steam at that temperature is. Options are 6 centimeter cube, 60 centimeter cube, 0.6 centimeter cube, or 0.06 centimeter cube. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be answer number C, that is option number C. So the density of liquid water is 1 gram centimeter cubic inverse. The density of water vapor is given as 0.0006 gram centimeter cubic inverse. So mass of 1000 milliliter stream will be 1000 multiplied by the given density of water vapor. It is coming out as 0.6 gram. Therefore, since the volume of liquid water will be is equal to mass of 1000 milliliter stream upon density of liquid water. So volume will be equal to 0.6 gram upon 1 gram centimeter cubic inverse. So the volume is coming out as 0.6 centimeter cube. Hence, option C is the correct answer. Moving on to the next question, question number 8. Experimentally, it was found that a metal oxide has formula M0.98O. So metal M is present as M2 positive and M3 positive in its oxide. Fraction of the metal which exists as M3 positive would be. Options are 4.08%, 6.05%, 5.08%, or 7.01%. You have 10 seconds to solve this question. After that, we will see the answer. So, the correct answer will be option A. So, it is given that metal oxide is M0.98O. Let X ions of M in +3 oxidation state is present. Therefore, 3X plus the metals will be 0.98 minus X, rest of metals multiplied by 2. The oxidation state of O will be equal to 2. From this equation, X is coming out as 0.04. So percentage of M in +3 state will be equal to 0.04 divided by 0.98 multiplied by 100, which is 4.08%. Hence, the option A is the correct answer. Moving on to the next question, that is question number 9. Which of the following order of root mean square speed of different gases at the same temperature is true? Options given are here. So the root mean square speed for H2 is greater than root mean square speed for CH4, is greater than root mean square for NH3, is greater than root mean square for CO2. Or root mean square for H2 is less than root mean square of CH4, is less than root mean square speed of NH3, is less than root mean square speed of CO2. Or root mean square speed of H2 less than root mean square speed of CH4, greater than root mean square speed of NH3, greater than root mean square speed of CO2. Or root mean square speed of H2 is greater than root mean square speed of CH4, less than root mean square speed of NH3, less than root mean square speed of CO2. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so correct option is option number A. So the correct order of root mean square speed of different gases at the same temperature is given by this. The highest in H2, then CH4, then NH3. We know that the root mean square speed is inversely proportional to the m, right? The mass. So more the mass of the molecule, less will be the root mean square speed of the molecule. Hence, we can get this correct order of root mean square speed. Hence, the option A is the correct answer. Okay, moving on to the next question, question number 10. The behavior of a real gas is usually depicted by plotting compression factor Z versus P at a constant temperature. At low temperature and low pressure, Z is usually less than 1. This fact can be explained by van der Waals equation when, so the options are, the constant A is negligible and not B. The constant B is negligible and not A. Both the constant A and B are negligible. Both the constant A and B are not negligible. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option number B. So at low temperature and low pressure, Z is usually less than 1. This fact can be explained by van der Waals equation when the constant B is negligible and not A. So this is the equation for the van der Waals equation, and here B is negligible, not A, so B will be negligible, so the formula will become this, and on multiplying the V inside the bracket, we get this equation, and on divided by nRT from both sides, we get this equation, and finally Z will be coming out as 1 minus A upon NV by NVRT. So we can clearly see that Z will be less than 1, and this is present when the B is negligible and not the A. Hence, option B is the correct answer. Moving on to next question, that is question number 11. When a capillary tube of diameter 0.4 mm is dipped in a liquid having density 800 kg meter cube inverse, then the height of liquid in the capillary tubes rises to 4 cm. The surface tension of the liquid is G is given here as 9.8 meter per second square. So the options are 1.6 into 10 to the power minus 2 Newton meter inverse, 5.6 into 10 to the power minus 2 Newton meter inverse, 6.3 into 10 to the power minus 2 Newton meter inverse, or 7.3 into 10 to the power minus 2 Newton meter inverse. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be the option number C. So this is the solution. The surface tension will be equal to RHDG by 2, where R is the diameter given here, H will be the height of the liquid in the capillary, D will be the density, and G is given here divided by 2. On putting the values, we found that the surface tension of the liquid is coming out as 6.3 multiplied by 10 to the power minus 2 Newton meter inverse. Hence, option C is the correct answer. Moving on to the next question, that is question number 12. So when a sample of gas is compressed at constant temperature from 15 atmosphere to 6 atmosphere, its volume changes from 76 centimeter cubic to 20.5 centimeter cubic. Which of the following statements are possible explanations of this behavior? First, the gas behaves non-ideally, the gas dimerizes, the gas is absorbed into the vessel walls. So options are first, second and third, first and second only, second and third, only first. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option number D. So when a sample of gas is compressed at a constant temperature from 15 atmosphere to 6 atmosphere, its volume changes from 76 centimeter cubic to 20.5 centimeter cubic. And this behavior shows that gas behaves non-ideally. Hence, option D, that is the gas behaves non-ideally, that is option only the first part is correct. So option D will be the correct answer. Okay, so moving on to our next question, that is question number 13. So for a crystal, the angle of diffraction 2 theta is 90 degree. And second order line has a D value of 2.28 angstrom. The wavelength in angstrom of X-rays used for Bragg's diffraction is. So options are 1.612, 2, 2.28 or 4. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be option number A. So given the angle of diffraction, that is 2 theta, is 90 degree. So theta will become 45 degree. So the distance between the two planes is given by D, that is 2.28 angstrom, which is given in the question, and N is equals to 2 here. So the Bragg's equation we know is n lambda equals to 2d sine theta. And on putting the given values in this equation, we find out that lambda, that is wavelength in angstrom, will be equal to 1.612, right? So option A is the correct answer. Moving on to next question, question number 14. How many unit cells are present in a cube-shaped ideal crystal of NaCl of mass 1 gram? The atomic mass of sodium and chlorine is given here. So options are 2.57 into 10 to the power 21, 5.14 into 10 to the power 21, 1.28 into 10 to the power 21, or 1.71 into 10 to the power 21. You have 10 seconds to solve this question. After that, we will see the answer. Okay, so the correct answer will be the option A. So mass of one unit cell will be equal to volume into density. So we just interchange the terms of density formula. So mass will be volume into density, and volume is A cube into D, and density is mz divided by Avogadro's number into A cube. So A cube will be cancel out, and mz upon Na will multiply by m, which is equals to this term, this gram. So number of unit cell in 1 gram will be 1 by m, that is this upon this, which will be equal to 2.57 multiplied by 10 to the power 21. So the option correct, the A option is the correct option. Moving on to our last and next question, that is question number 15. Schottky defects occur mainly in electrovalent compounds, where options are positive ions and negative ions are of different size, positive ions and negative ions are of same size, positive ions are small and negative ions are big, positive ions are small, are big, and negative ions are here. Okay, so positive ions are big and negative ions are small. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, so option B is the correct answer for this. So Schottky defects occur mainly in electrovalent compounds where positive ions and negative ions are of same size. That's why option B, which states this, is the correct answer for this question. Okay. Thank you.